Okay, so in this topic we will discuss about the dot products in orthogonal sets. Dot products and orthogonal sets. So the brief theory of this is that the dot product between two vectors u and v, so u dot v is represented by this, and the product of this the result of this product is a scalar, and this is determined by u transpose v. Okay, it is determined by u transpose v. So if, for example, then in this case, since it is a transpose, so as an example, if you see that if u is, say, u1, u2, u3, and v is v1, v2, v3. Okay, so these are the two vectors. So then u dot v will be equal to, then this transpose of that will be u1, u2, u3, and then v will be v1, v2, v3. So this product is defined because this is 1 by 3 matrix, this is 3 by 1 matrix, so the resultant of this product will be 1 by 1 matrix, so it will be u1 v1 plus u2 v2 plus u3 v3. So since this is a 1 by 1, so we can also treat it as a scalar as well. So this is the concept of dot product of the two vectors. Whereas the orthogonal sets are those vectors if their dot product is 0. So if you take two vectors u and then v, and then their dot product is 0, so then these two vectors are called as the orthogonal. Orthogonal. So sets of such vectors is called as the orthogonal sets. Okay, so and then there are some further concepts which I will describe when doing the problems. So numerical problems. So for example, now I have a vector u1 is equal to 1 minus 2 1, and I have vector u2 equal to 3 2 minus 1. So in part A, what is u1 dot u2? So what is the dot product of these two vectors? So from the previous definition, so dot product of these two vectors will be 1 times 3 plus minus 2 times 2 and plus 1 times minus 1. So it will be 3 minus 4 minus 1. So 3 minus 4 minus 1, it will be minus 2. Minus 2. 3 minus 4 is minus 1. Minus 1 minus 1 is minus 2. So u1 dot u2 will be minus 2. In B, if it is asked that what will be minus 2 u1 dot u2, so in this case we will multiply first 2 by u1 and then we will take their dot product, or alternatively minus 2 u1 dot u2 will be also equal to u1 dot u2. Okay, u1 dot u2, 2 times u1 dot u2, but u1 dot u2 we already know that it is minus 2, so it is the minus 2 times minus 2, it will be then plus 4. Okay, the third is that in part C, what is the norm of u1. So what is norm of u1? Norm is of u1 is represented by this two double lines on the both sides. Norm of u1. Norm of u1 is actually the same as the length of vector. Length of vector. And the length of vector is defined by this formula. So length of any vector is square root of that vector dot product by the same vector. Okay, u1 dot u1 and then taken by the square root. So in this case, what will be that? So u1 dot u1 means we will take the components of u1 and then take their square, and then we add them together, and then after that we will take their square root. So it will be 1 square plus 2 square. So minus 2 square is essentially 2 square. So you can even write bracket and minus 2 square over here plus 1 square. So it will be then under root square root of 6. So square root of 6 is the norm of u1. Norm of u1. Okay, so this was one example with the basic operations for the dot product. Next example is verify for two vectors x and y this expression. 2 times the norm of x square plus 2 times the norm of y square is equal to norm of x plus y square plus norm of x minus y square. Okay, so if suppose we want to verify this expression, so how we can verify it? So we can start from the right hand side. Okay, so the right hand side is this x plus y norm square plus x minus y norm square. So according to the definition of the norm, x plus y norm is equal to square root of x plus y dot x plus y. So it's if we take it square, then that square root will not appear. So for example, if I say that x, if x is a vector, okay, its norm will be x dot x, okay, square root. So if I take the square root of both sides, so it will be x norm square, that will be equal to x dot x. So similarly for x plus y square, so its norm will be x plus y dot x plus y, okay, and then it will be x plus x minus y, for this x minus y, x minus y dot x minus y. So now we will take this according to the rules of the dot product. So we will take x plus y, that will be dot x, and then x plus y, that will be dot y, okay, and then x minus y dot x, and then plus x minus y dot minus y, okay, right, in this case. So x, so it will be x dot x plus y dot x, and then plus x dot y plus y dot y plus x dot x minus y dot x, and plus sorry, it will be then over here it will be then x into that will be minus x dot y, and then plus y dot y. So what is cancelled out? Y dot x minus y dot x, these two terms are cancelled. And if is there any other term which is cancelling out? X dot y cancels with minus x dot y. Okay, and then we can collect all the other terms. So 1, 2, 3, 4, these 4 terms are left, so we can collect all the other 2 terms. So we will get 2 x dot x, okay, and then plus 2 y dot y, plus 2 y dot y. So what we get is 2 x dot x is actually the what is this? What is x dot x? X dot x, according to the definition of the norm, is the norm square. Okay, so this is x square and then 2y norm square. So hence we have proved it. So this is the left hand side. So left hand side. So hence proved. Okay, the next example we take to determine if the following sets forms an orthogonal set. Okay, so example. So suppose if we have a set, a subspace of these vectors 1 minus 2 minus 1 and 1 minus 1 minus 1 and 1 0 1. So we want to know whether these three members of the set, 3 vectors, are orthogonal. Okay, yeah, so orthogonality we have to check. Orthogonality check. So the orthogonality check is obtained when we take the dot product of the vectors and the dot product is equal to 0. So we have to take, we say, for example, if this is set A, this is set B, this is set C. So we take A dot B, so it should be 0. Okay. A dot C, it should be 0. B dot C should be 0. All the 3 possible combinations should be 0. So we need to check it. So if it is 0, if all the 3 possible combinations are 0, then we can say that this is an orthogonal set. Okay. So what is A dot B? A dot B will be 1 minus 2 minus 1. Okay, dot 1 minus 1 minus 1. So what will be that? It will be 1 into 1, 1 into 1, minus 2 into minus 1, and minus 1 into minus 1. Okay, so it will be 1 plus 2 plus 1, right? So it will be 1 into 1, 1, plus 2, 3, and 3 minus 3 plus 1 is 4. Okay, let me check again. So 1 minus 1, 2, 1. Okay, I did a mistake over here. It is 1, 2 minus 1. Okay, 1, 2 minus 1. So it was 2. Okay. So 1 minus 2 minus 1 minus 1 plus 1, that is 0. Okay, so A dot B is 0. What is A dot C? A dot C is 1, 2 minus 1, and C is 1, 0, 1, 1, 0, 1. So it is 1 into 1 plus 2 into 0 and plus minus 1 into 1. I will continue it in the next video clip.